Hello everyone, I am Balaji Rao. Welcome to BR Max class. Till now, what we learned in continuity? We learned the definition of continuous function and we learned how to check function is continuous function, how to check points of discontinuity. In this class, what we are going to learn? You observe this question number 26. What is there in question number 26? Find the value of k such that the given function is continuous at x equal to pi by 2. So whatever the problems I am going to do today, they are all like this. Find the value of k such that given function is continuous at x equal to pi by 2. You see this one. Find the value of k such that function is continuous at x equal to 2. And you observe this question. Find the value of k such that function is continuous at x equal to pi. These problems are important in exam point of view. Find the value of k such that this function is continuous at x equal to 5. These are very easy problems. If you are good in the definition of a continuous function, then you can understand these things easily. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. Okay, you observe this question number 26. What they are asking in the question? Find the value of k. We need to find the value of k. For that, what they given? They given that this function is continuous at x equal to pi by 2. They given that this function is continuous at x equal to pi by 2. Then we need to find the value of k. Okay, first thing, I'll write the given information. What is the given information? 1 minute. I'll write the given information. Given information is what? Given. What they given? F of x is continuous. At what point they given? Look here, indicated point. They given that this function is continuous at x equal to pi by 2. So I'll write that this function is continuous at x equal to pi by 2. They given that f of x is continuous at x equal to pi by 2. When we say f of x is continuous at x equal to pi by 2, answer, when we say f of x is continuous at x equal to pi by 2, here we know this. This is the hero of this story. Limit x approaches to pi by 2. F of x equal to f of pi by 2. Then we say that function is continuous at x equal to pi by 2. When this holds good, then we say that f of x is continuous at x equal to pi by 2. From the beginning of this chapter, we are discussing same point only. Okay, so when f of x is continuous at x equal to pi by 2, then limit extends to f of x, limit extends to pi by 2, f of x equal to f of pi by 2. This holds good. Now, we are not trying to prove this one. We know this result, we have this result because in the question only they given that this is continuous at x equal to pi by 2. Okay, you observe here, by using this equation, we need to find the value of k. Okay, here important point is x approaches to pi by 2. What it mean? X approaches to pi by 2 means all x values are slightly less than pi by 2 or all x values are slightly greater than pi by 2 but not pi by 2. Here, but not pi by 2. X approaches to pi by 2 means x values are less than pi by 2. When x values are less than pi by 2, then we need to choose this function only. Less than pi by 2 means not equal to pi by 2 na? Then we will choose this first function. When x approaches to pi by 2 means there is a chance that x values are greater than pi by 2. When x values are greater than pi by 2, that means that x values are not equal to pi by 2. In that case also we will choose first function only. What I am trying to say, to find the value of k, in this no need of left hand limit, right hand limit. Directly we can calculate. So I'll calculate. What I'm going to do, I'll calculate this one first. Let's see what happened. Limit x approaches to pi by 2. Limit x approaches to pi by 2. What is the function here? X approaches to pi by 2 means x not equal to pi by 2, x values are slightly less than pi by 2 or x values are slightly greater than pi by 2. So that means this is the function we need to choose. So here in place of f of x, what I'll write, what is the function? K cos x divided by pi minus 2x. This is the function. Okay, equal to, here f of pi by 2, f of x, f of pi by 2. In place of x, pi by 2 is there. When x equal to pi by 2, what is the function to choose? The function is 3. That is what they given in the question. So I'll write that equal to f of pi by 2 is what? F of pi by 2 is 3. Now I'll calculate this limit. How to calculate this limit? Actually, for any problem in limits chapter, first we'll try by direct method. Okay. So what I'll do, in the given function, I'll substitute pi by 2. In place of x, you write pi by 2. Cos pi by 2. What is cos pi by 2 value? Cos pi by 2 value is 0. So numerator will become 0. In the denominator, in place of x, you write pi by 2. In place of x, if you write pi by 2, this 2 will get cancelled. Then you will get pi minus pi 0. So when I put x equal to pi by 2 in this is of the form 0 by 0. We are getting indeterminate form. Then we need to look for alternate methods. So what I will do here, I know this formula. What formula? In limits chapter we learned this. Limit x approaches to 0, sin x divided by x equal to 1. I know this formula. I just want to use this formula. To use this formula, I want sin x in the numerator. Here cos x is there. Na? In place of this cos x, I want sin x. I know how to write it. Let's see how we'll do this further. Limit x approaches to pi by 2. Limit x approaches to pi by 2 k into, here cos x is there. Na? I want to write in terms of sine. What is the method? Trigonometry. Trigonometry formulas plays very important role. You know that sin pi by 2 minus theta is cos theta. Sin pi by 2 minus x is cos x. We know this formula from trigonometry. Sin pi by 2 minus x is cos x. So in place of cos x, what I can write? I can write sin pi by 2 minus x. So what I'll do here, in place of cos x, I'll write sin pi by 2 minus x. Okay. K into, in place of cos x, I'll write sin pi by 2 minus x whole divided by. Okay. Here what I'll do, in the denominator, I'll take 2 common. I'll tell you why I am taking 2 common. First I'll take 2 common. In the denominator, you take 2 common. Okay. Take 2 common. What you will get if you take 2 common? This is pi by 2 minus x. You observe here, if you multiply these two, again you will get pi minus 2x only. You observe 2 into pi by 2 is pi minus 2 into x is 2x. So what I am trying to say, if you multiply these two things, again you are going to get this one. In the denominator, I just taken 2 common. Okay. That equal to 3. Okay. In limits chapter again in limits chapter we have one basic formula, algebra of limit. Limit x approaches to a k into f of x. This can be written as k times of limit x approaches to a f of x. What is this? Very simple thing. Constant into function is there. Then we can take constant outside and we can calculate limit of the function. So what I am trying to say, here you observe k by 2 is there. K by 2 is the constant. You can take this k by 2 outside of the limit from this formula. So you take k by 2 outside, take k by 2 outside, k by 2 outside. Okay. Limit x approaches to pi by 2. Here I need to tell you one very important point. Look here, x approaches to pi by 2 means, what do you know about pi by 2 minus x? Pi by 2 minus x approaches to what? X approaches to pi by 2 means x values are nearer to pi by 2. Na? In place of x, you write pi by 2 here. Pi by 2 minus pi by 2 is what? Pi by 2 minus pi by 2 is 0. What I am trying to say, x approaches to pi by 2 means pi by 2 minus x approaches to 0. This is very simple logic. In place of x, here you write pi by 2 minus pi by 2 is 0. So what I am trying to say, x approaches to pi by 2 means pi by 2 minus x approaches to 0. So what I will do, here x approaches to pi by 2 is there. Na? In place of x approaches to pi by 2, I will write pi by 2 minus x approaches to 0. I will write that pi by 2 minus x approaches to 0. Actually k by 2 constant to be written outside. Now what is remaining, that I will write sin pi by 2 minus x divided by pi by 2 minus x equal to 3. Okay. I hope you are understanding, right? Good, right. Now, observe this formula. We know this formula, limit x tends to 0, sin x by x equal to 1. This formula holds good in this case. You observe this carefully. Here x is there, here x is there, here x is there. What expression is present here? If same expression is present here and x approaches to 0, then only we can apply this formula. Okay. Now what I'll do, I'll try to apply this formula here. Please observe here, pi by 2 minus x. pi by 2 minus x, pi by 2 minus x, and this value is approaching to 0. So for this problem, can I apply this formula? Yes, we can apply. So as per this formula, what this expression will be? This expression will be equal to 1. So what you will get here, k by 2 into this whole value. This value will be equal to 1 because of this formula. We have this formula. Okay, equal to 3. Okay, if I simplify this little bit, what you will get? You take this 2 to the right hand side, what you will get? K equal to 3 into 2. 3 into 2 is 6. What they are asking in the question? Find the value of K. We got K value here. K value is 6, correct or not? What they are asking in the question? Find the value of K such that function is continuous at x equal to pi by 2. I started with function is continuous at x equal to pi by 2. I started simplifying. I got that K value is 6. I hope you understand this. Understand or not? Good. Now we'll move to the second problem. You see this question, what they are asking? Find the value of K. We need to find the value of K. For that, what they given? They given that the function is continuous at indicated point. What is the indicated point? Indicated point is at x equal to 2. So first thing, I'll write the given information in the question. What is the given information? They given that given f of x is continuous. F of x is continuous at x equal to 2. They given this function is continuous at x equal to 2. When f of x is continuous at x equal to 2, then what you know? When we say function is continuous at x equal to 2, we say that when limit x approaches to 2, limit x approaches to 2, f of x equal to f of 2. Limit x approaches to 2, f of x equal to f of 2, then we say that the function is continuous at x equal to 2. Right? Actually, we are not trying to prove this one. We are not trying to prove this one. We know this one. By using this result, we need to find the value of K. Okay. Here the problem is there. You observe the given function. When x is less than 2, we need to choose the first function. When x is greater than 2, we need to choose the second function. Here, x approaches to 2 means, what are x values? There is a chance that x values are less than 2. There is a chance that x values are greater than 2. X approaches to 2 means all x values are slightly less than 2 or slightly greater than 2 but not 2. So here, to calculate this one, we need to calculate left hand limit, right hand limit. So actually what the point is, they given that they given this equation holds good. When limit of a function exists, what they are saying that this holds good. This holds good means what? This holds good means this value exists, and both values are equal. When limit of a function exists, when left hand limit equal to right hand limit, then we say that limit of the function exists. So what I can write here, limit x approaches to 2 from left, f of x. Value must be equal to left hand limit must be equal to right hand limit. Limit x approaches to 2 from right, f of x equal to f of 2. I hope you understand. This holds good. It means that left hand limit will be equal to right hand limit. Then only we say that limit exists and these two values are equal to this value. Whatever values we will get here, that value is the limit of the given function. Okay. So here, listen, limit. I'll try to calculate this one. Okay, limit x approaches to 2 from left. X approaches to 2 from left means what are the x values? All x values are less than 2. When x values are less than 2, which function to choose? This function. What is this function? Kx square. Okay. Kx square equal to limit x approaches to 2 from right. X approaches to 2 from right means all x values are greater than 2. When x values are greater than 2, we need to take this function x equal to 3. Okay. So in place of f of x, I'll write 3 equal to, actually this equal to this and this equal to this. In some cases, this f of 2 is useful. Actually, here it is not useful. So just I am equating this one and this one to find the value of k. Okay, I am just using this part only. If necessary, I'll use this also. Okay. So what I'll do now, what I need to do, I need to calculate this limit. How to calculate this limit? By direct method. What is the direct method? In the given function, wherever x is there, there you write 2. In the given function, wherever x is there, there you write 2. Okay, write 2. What you will get? K into, in place of x, if you write 2, this is become 2 square. 2 square is what? 2 square is 4. Okay, k into 4 equal to, how to calculate this limit? Direct method. Wherever x is there, there we will write 2. But in the given function, x is not there. So what you will get here, this is direct answer. This is 3. Okay. So from this, what is k value? K value is 3 divided by 4. So they are asking to find the value of k. I got k value as 3 by 4. Correct? These problems are very easy. In this, what is the thing you need to know? Limit exists. When limit exists, when left hand limit equal to right hand limit, then limit of a function exists. As they are saying that this exists, we'll equate these two to get the value of k. I hope you understand this. Yes or no? That's good. Now you see this question number 28, what they are asking in the question? Again, find the value of k. We need to find the value of k. For that, what they are saying, this function is continuous. Given function is continuous at x equal to pi. Here you need to observe things here. When x is less than pi, we need to choose this first function. When x is greater than pi, then we need to choose the second function. First, to solve this problem, first I'll write the given information. What is the given information? Given f of x is continuous. Given f of x is continuous. Given f of x is continuous at x equal to pi. Given that f of x is continuous at x equal to pi. This information they given. When we say f of x is continuous at x equal to pi, from the beginning of this chapter we are discussing. When we say f of x is continuous at x equal to pi, if limit x approaches to pi, f of x equal to f of pi. Limit x approaches to pi, f of x equal to f of pi, then we say function is continuous at x equal to pi. Actually, in the given question, they are given it is continuous at x equal to pi. It is continuous at x equal to pi means this condition holds good. By using this condition, we need to find the value of k. We need to find the value of k. Okay. So what I'll do here, you observe here, they are saying that this equation holds good. That means this limit exists. Limit exists means what? Left hand limit will be equal to right hand limit. So I'll write here, limit x approaches to pi from left, f of x equal to limit x approaches to pi from right, f of x equal to f of pi. This holds good means these two are equal and this value will be equal to this value. This we learn from limits chapter. This is easy point only. Okay. Now I'll try to calculate this one and this one. Okay. Limit x approaches to pi from left. X approaches to pi from left means all x values are less than pi. When x values are less than pi, which function to choose? I need to choose this function kx plus 1. So, in place of f of x, I'll take kx plus 1 equal to limit x approaches to pi from right. X approaches to pi from right. What it means? It means that all x values are greater than pi. When x values are greater than pi, then which function to choose? I need to choose cos x. So, in place of f of x, I'll write cos x. Cos x. Here, the point is they given this equal to this and this equal to this. These three things are equal. But I am going to use these two things only. If necessary, I will use this point or else not necessary. Yes, Shashank. Good morning. Okay. Now, what I will do, I am going to simplify this. I am going to equate these things. Listen, I will calculate this one. How to calculate this one? By direct method. What is direct method? In the given function, wherever x is there, there you will write pi. Okay. So, what you will get? K into pi plus 1 equal to, how to calculate this one? in the given function, wherever x is there, there we will write pi. So in place of x, you write pi. Then what you will get? This will become cos pi. Okay, k pi plus 1 equal to, in trigonometry table you learn cos pi value. What is the value of cos pi? The value of cos pi is minus 1. So you write minus 1. Now I need k value now. So you take this plus 1 to this side. Then what you will get? K pi equal to minus 1, that is minus 2. From this you can write the value of k. What is the value of k? The value of k is minus 2 divided by pi. What they are asking in the question, find the value of k when the function is continuous at x equal to pi. So what I started that function is continuous at x equal to pi, and I used this equation. I started simplifying. I got the value of k. What is the value of k? The value of k is minus 2 divided by pi. I hope you understand this. Understand or not? That's great. You observe this question number 29. What they are asking? Find the value of k. We need to find the value of k. For that, what they given? The function is continuous at the indicated point. They are saying that function is continuous at an indicated point. You observe, this is the function they given, and they are saying that this function is continuous at x equal to pi. So to do this problem, first I will write the given information. What is the given information? Given. What they given? Given f of x is continuous. F of x is continuous at x equal to 5. This is what they given. The function is continuous at x equal to 5. When we say function is continuous at x equal to pi, what is the hero of this story? When we say function is continuous at x equal to 5, limit x approaches to 5, f of x equal to f of 5. When this holds good, then we say that function is continuous at x equal to 5. But the point here, they given in the question, it is continuous at x equal to 5. That means this equation holds good. We can use this equation. We are not going to prove this equation. We will use this equation to find the value of k. Okay. Here you observe limit exists. Limit exists. What it means? Limit exists means left hand limit exists, right hand limit exists, and both will be equal. So from this, what I can write? I can write like this. Limit x approaches to 5 from left, f of x equal to limit x approaches to 5 from right, f of x equal to f of 5. I hope you are understanding. This exists means, it means left hand limit will be equal to right hand limit. Left hand limit equal to right hand limit. So I am going to calculate these two things. Let's see what happened. Limit x approaches to 5 from left. X approaches to 5 from left means all x values are less than 5. When x values are less than 5, which function to choose? We need to choose this function. What is this function? Kx plus 1. In place of f of x, you write kx plus 1 equal to, you observe this, x approaches to 5 from right. X approaches to 5 from right. That means all x values are greater than 5. So limit x approaches to 5 from right. That means all x values are greater than 5. When x values are greater than 5, which function to choose? We need to choose the function 3x minus 5. So in place of f of x, we will write 3x minus 5. Okay, actually what happened? They given these two or these three are equal, but I will use these two things. These two things are enough to find the value of k. If necessary, then I will use this third one. I hope you are understanding. We can use this equal to this. We can use this equal to this. We can use this equal to this. Any two things are enough here to find the value of k. I am going to use these two things. Okay, you observe here how to calculate this. How to calculate this limit? In limit chapter, we can do this problem by direct method. What is direct method? In the given function, wherever x is there you write 5. Okay, so what you will get here? K into 5 plus 1. K into 5 plus 1 equal to, how to calculate this? Direct method. What is direct method? In the given function, wherever x is there we will write 5. Okay, write 5. 3 into 5, 15. 15 minus 5. Okay, that equal to 5k plus 1 equal to 15 minus 5 is 10. Okay, that equal to, what is 5k from this? You take this 1 to the right hand side. What you will get? 10 minus 1 is 9. Correct? What is k from this? K equal to 9 divided by 5. So we got k value as 9 divided by 5. We got k value as 9 divided by 5. Actually what they are asking in the question, find the value of k. And this is the given function, right? So find the value of k when the function is continuous at x equal to pi. They given. I taken that function is continuous at x equal to 5 and I got that k value is 9 by 5. So with this the 4 problems what we decided to complete today, we completed. I hope you understand these problems. These are very easy problems. Right. If you like this video, please drop a like. That gives me more energy to create many videos like this. And share this video with your friends. And very soon, within 1 or 2 classes, I am going to complete this continuity part. Then let me decide whether to do objective bits or continuation of this chapter. Okay. Thanks for watching. Take care. Bye-bye.